Notes for section 1.5, exploring angle pairs. The objective for today is to identify special angle pairs and use the relationships to find angle measures. So the first thing we're going to look at is some definitions of types of angle pairs. So here are 4 types of angle pairs: adjacent angles, vertical angles, complementary angles, and supplementary angles. Adjacent angles are 2 coplanar angles with a common side, a common vertex, and no common interior points. So if you look at the 2 pictures off to the right, angles 1 and 2 are right next to each other. That means that they're adjacent. There's no spaces in between. They don't overlap each other. They do have a common vertex, which is right here. They're in the same plane, and they share a common side, which is right there. Same with angles 3 and 4. Vertical angles are 2 angles whose sides are opposite rays. So for this one, you are looking for, sorry about that, hit something. You are looking for this X that these angles make right here. The reason for that is because their sides are opposite rays. So when you look at angle 1 and angle 2, they're opposite each other. And this side, here, let me erase this once. This side of angle 1 is an opposite ray to this side of angle 2. This side of angle 1 is an opposite ray to this angle, or this ray from angle 2. So 1 and 2 are vertical angles. Complementary angles are 2 angles whose measures have a sum of 90. So it's kind of like 2 angles that form a right angle are complementary. Each angle is the complement of the other. Notice the pictures here. Complementary angles can be adjacent, but they don't have to be. The only stipulation is that they have to add up to 90. So if you look at these 2 angles right here, they are not adjacent, but 47 plus 43 does equal 90. Okay, when you look at the next one, supplementary angles are 2 angles whose measures add up to 180. They can be next to each other. They don't have to be next to each other. So if I look at, for instance, these 2, 43 plus 137 would be 180. That would form a supplementary pair. Wait, I don't want to add it up there. Supplementary can be adjacent or add up to 180. I should word that different. Adjacent and add to 180, or just add to 180. Problem number 1, is the statement true, and explain. So in the picture is angle BFD and angle CFD adjacent. Now let's go back and read what adjacent angles are. Adjacent angles are 2 coplanar angles, so they have to be in the same plane. They have to share a common side. They have to share a common vertex, but they cannot share any common interior points. Okay, so let's look at this. They share the same vertex. So same vertex. They share a side, which is ray FD. But point C is on the interior of angle BFD. So adjacent really means next to, not overlapping. Okay, how about AFB and EFD are vertical angles? So AFB is this one, and EFD, oops, I'll make that a different color. Okay, so what we have to remember about vertical angles is that you need a perfect X. So if we look at that, this one makes a perfect line, but this one doesn't. So I'm going to say no. Sides are not opposite rays. How about AFE and BFC are complementary? So AFE is 62 degrees and BFC is 28 degrees. So we have to check, does 62 plus 28 equal 90? And yes, it does. So I'm going to say yes this time. You want to pause the video and work on Got It question number 1, and you can come back and check your answers. So is AFE and CFD vertical angles? AFE and CFD. Okay, so these form an opposite ray, those form an opposite ray, so I'm going to say yes. Sides form opposite rays. Okay, our BFC and DFE supplementary. So BFC is 28. DFE is 118. So to be supplementary, they need to make 180 degrees. I can tell you already that these do not add up to 180. They only add up to 146, which doesn't equal 180, so no. Are BFD and AFB adjacent? So BFD and AFB. Okay, so remember, in English, if you are adjacent to something, you are next to. No spaces. So with these, they share a vertex and a side and no common interior points. So yes. Okay, so a concept summary, finding information from a diagram. There are some relationships you can assume to be true from a diagram that has no marks or measures. There are other relationships you cannot assume directly. For example, you can conclude the following. You can assume that angles are adjacent, or you can figure that out looking at the picture. You can assume that angles are adjacent and supplementary by looking at a picture, and that they're also vertical. So these are all yeses. You cannot conclude the following from an unmarked picture. Cannot conclude. You can't conclude that they're congruent unless they tell you. So if it's unmarked, you don't know. You can't assume that just because it looks like a right angle, it is a right angle. Remember, it needs that little box to determine if it's a right angle. So if it's unmarked, you can't tell. And you also can't tell that they're complementary basically because there's no box. So let's look at one. What can you conclude from the information in the diagram? All right, so sorry about that. So we're going to look for adjacent, adjacent and supplementary, and vertical. All right, so angle 1 is congruent to angle 2 because of those little arc symbols. Angle 1 and angle 2 are adjacent. And there's lots of other pairs in there as well. 1 and 5 are adjacent. 5 and 4 are adjacent. 4 and 3. And 3 and 2. So you could pick any of those. 4 and 5 are supplementary. The way that we know that is because there's a line that forms at the bottom, and those two form 180 degrees. You could also say 4 and 3 are supplementary as well. If you look at these two, they form an X. So you can say angle 3 and angle 5 are vertical. I think that's about it. You can pause the video now and try got it question number 2. Can you make each conclusion from the information in the diagram and explain? So can you assume that TW and WV are the same? TW is marked with a hash mark. VW is marked with a hash mark, so I'm going to say yes. They are marked. Is PW the same as WQ? No, not marked. Okay, so they don't have these little hash marks like that. They need those to figure that out. Is TWQ a right angle? Well, it sure looks like it is, but we're going to say no because it is not marked. With that little right angle symbol. Does TW bisect PQ? So TW, this one, does it make these two parts the same? And I'm going to say nope, they're not marked. Okay, so just make sure that when you're looking at anything, it basically needs to be marked. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. The angles form a straight angle. So from at the beginning of the lesson when we talked about straight angles, this right here is a straight angle because the rays that form it are opposite each other. Okay, so make sure that you copy this into your postulates and theorems. If two angles form a linear pair, then they are supplementary. So linear pair means straight line. If they form a straight line, then they add up to 180. Problem 3. KPL and JPL are a linear pair. Okay, that means they form a line. Okay, so that's what we're looking at. KPL is 2x plus 24. Angle JPL is 4x plus 36. What are the measures of the two? Well, if they're a linear pair, then they add up to 180. So 2x plus 24 plus 4x plus 36 is equal to 180. So we'll put like terms together, 6x, and then 24 plus 36 is 60. And we'll subtract 60 from both sides. And then we'll divide by 6. And they want the measures of those two pieces. So the measure of angle KPL is equal to 2 times 20 plus 24. So 40 plus 24 would be 64. The measure of angle LPJ, or JPL, would be 4 times 20 plus 36. So that would be 80 plus 36, or 116. And remember that those two together should add up to 180. 64 plus 116 does equal 180. So we have done that one correctly. An angle bisector is a ray that divides an angle into two congruent angles. So this one right here, ray AY, makes this part congruent to this one, and they are marked that way. So you can kind of see that. So when it says anything and you don't have a picture, draw a sketch of it to see if you can figure out what they're talking about. So we have an angle DAB. A has to be the vertex. And it says AC bisects it. So you have to know what bisect means. AC basically cuts that angle in half, so it makes this part the same as this one. Now it says that DAC is 58. They want to know what DAB is, the whole entire thing. Well, if DAC is 58, then CAB is 58. So 58 times 2 is going to be the entire thing, which is 116. So the measure of angle DAB equals 116. Pause the video, forgot at question number 4. So KM bisects it, so this part is the same as this one. JKL, that's the entire thing, is 72. What is JKM? So if it splits it into two equal parts, we're going to divide 72 by 2. Each part is going to be 36 degrees. So measure of angle JKM is equal to 36. And that's it. Please come with questions tomorrow in class. We'll also practice some on the whiteboards and go from there.